What if I told you that when you play a cloud game, your PC isn't running it, your console isn't running it, not even your phone is running it? Somewhere, in a massive warehouse filled with thousands of servers, a powerful computer is playing the game for you, and you're just watching a live video of it. But here's the insane part. You can still control it in real time. How is that even possible? Cloud gaming is basically this. Instead of installing a game on your computer, you stream it, like Netflix. But instead of just watching a movie, you're controlling it. So when you press W to move forward, that signal travels across the internet to a powerful computer in a data center. That computer processes your input, renders the next frame, encodes it into a video, and streams it back to you, all in just a few milliseconds. Let's break it down. You press a key, that input signal gets sent from your keyboard to your router, to your internet service provider, across massive fiber optic cables, all the way to the cloud provider's data center. This is why latency matters so much, because every single millisecond counts. If your signal takes 40 milliseconds just to reach the server, that's already 40 milliseconds of delay before the game even knows you did anything. Once your input arrives at the data center, you're assigned what's called a virtual machine. This is basically a remote gaming PC just for you. It has its own CPU, GPU, RAM, and storage, just like your computer at home, except it's way more powerful. These machines are stacked in huge racks, thousands of them, all being aggressively cooled and connected to insane network speeds. This is similar to how normal cloud servers work, but they are specially optimized for one thing: graphics. When your input finally arrives, the server immediately updates the game state. It tells the virtual PC, hey, the player moved forward. Then, its powerful GPU renders the very next frame, generating a full-resolution, beautiful image of the game world. But here's the problem. Sending that raw image data back to you would be completely impossible. A single 1080p frame is about 6 megabytes uncompressed. At 60 frames per second, that would be 360 megabytes per second per user. It would literally break the internet. So instead, the server does something incredible. It compresses that frame instantly. It uses special hardware video encoders to shrink it down, using codecs like H.264, H.265, or the newer AV1. These are the exact same technologies that YouTube and Netflix use to send you videos. The server essentially turns your gameplay into a compressed video stream, on the fly. But it has to do this incredibly fast. If the compression takes too long, you feel input lag. That's why cloud gaming GPUs have dedicated encoders built right in, just for this task. Now that the compressed video is ready, it travels all the way back to you, from the data center through the internet backbone, to your ISP, to your router, and finally, to your device. Your device then decodes the video instantly and displays it on your screen. From your perspective, it feels like you're playing locally. But what you're really doing is watching a high-speed interactive live stream of a computer miles away. As you can imagine, cloud gaming lives or dies by one thing: latency. The total delay is the sum of everything. The time it takes for your input to travel, for the server to process it, for the frame to be encoded, for the video to travel back, for your device to decode it, and for your screen to display it. Even an extra 20 to 30 milliseconds is noticeable. That's why cloud gaming works best when you are physically close to the data center, you have a low ping, and your internet connection is stable and fast. Even if the latency is super low, you might still notice that cloud gaming can feel a little off. You might see a slight blur during fast motion, some blocky compression artifacts, or a loss of detail in dark scenes. That's because you're watching a compressed video, not raw game frames rendered by your own machine. Fast movement is much harder to compress efficiently, which is why fast-paced shooters can sometimes feel worse than slower-paced strategy or role-playing games. So if it's not perfect, why are companies pushing it so hard? Well, cloud gaming has huge advantages. For you, there are no downloads, no need to buy an expensive GPU, and no console required. You get instant access to your games on any device. And for the companies, it's a dream come true. There's no piracy. They don't have to worry about millions of different PC hardware combinations. They have centralized control over the experience, and it creates a steady subscription revenue stream. That's why giants like Nvidia, Microsoft, and Sony are investing billions. Of course, this all relies on you having a serious internet connection. For a good 1080p experience, you need a stable 15 to 20 megabits per second. For 4K, you're looking at 35 to 50, and it has to be stable. If your bandwidth suddenly dips because someone else in your house starts streaming a movie, The cloud gaming service will automatically lower the resolution or the stream will start to lag. This is also why the quality of your Wi-Fi connection is so critical. To make all this happen, companies build out mind-boggling infrastructure. They have dedicated GPU clusters inside those massive data centers we talked about. They use load balancers to distribute players across thousands of virtual machines. And, most importantly, they place edge servers near major cities. Some providers even put mini data centers inside city limits just to cut down on that physical distance. The closer you are to the server, the lower the latency, and the better the experience feels. So, will cloud gaming replace your gaming PC or console anytime soon? Probably not. Competitive gamers will always demand the absolute lowest latency that only local hardware can provide. The internet isn't perfect everywhere, bandwidth still costs money, and a local PC still gives you the absolute best, uncompressed image quality. But, as internet speeds get faster, as video encoding technology improves, and as edge computing expands to more cities, cloud gaming will get better. Much, much better. So the next time you press a button in a cloud game and your character moves, just remember the insane journey that signal took. Your input traveled across cities. A remote supercomputer rendered your world, compressed it into a video, and sent it back to you, all in less time than it takes to blink. That's not just streaming. That's some truly insane engineering. Thanks for watching, and I'll see you in the next one.